Problem number 9. A 5 kg object undergoes a time-varying force as shown in the graph below. If the velocity t equal 0 seconds is positive 1 meters per second, what is the velocity of the object at the time t equals 7 seconds? Solution. Here, because we have force depending on time, we can use equations for a change of momentum. It means that m delta v equal f delta t. And to find what is a total change of momentum, we just need to count what is the area under this graph. So total area is 4.5, which is area for this triangle, plus 8, which is area for this trapezoid, and total is 12.5. So it means that delta v equal 2.5 meters per second, and finally v equal 1 meters per second plus 2.5, which is 3.5. So correct answer is C, 3.5 meters per second. Problem number 10. A radio-controlled car is attached to a stake in the ground by a 3 meters long piece of string and is forced to move in a circular path. The car has an initial angular velocity of 1 radian per second and smoothly accelerates at a rate of 4 radians per second square. The string will break if the centripetal acceleration exceeds 2.43 by 10 power 2 meters per second square. How long can the car accelerate at this rate before the string breaks? Solution. First, we can find what is the maximum angular velocity we can reach, because maximum acceleration equal r maximum angular velocity square. This is how to find this maximum angular velocity. Next one is change of angular velocity. Change of angular velocity equal final angular velocity minus initial angular velocity. And total time will be change of angular velocity over angular acceleration, which is this expression, and after when we put numbers we will get 2 seconds, which is answer E. Problem number 11. The point mass M is connected to an ideal spring on a horizontal frictionless surface. The mass is pulled a short distance and then released. Which of the following is the most correct plot of the kinetic energy as a function of potential energy? Solution. For such motion we have energy conservation. It means that total energy E, which is equal kinetic energy plus potential energy, is constant. And from this formula we can write what is kinetic energy as a function of potential energy. That will be K equal E minus P, which is exactly E answer, correct one. Problems 12 and 13. The following information applies to questions 12 and 13. A paper helicopter with a rotor radius r and weight w is dropped from a height h in air with a density of ρ. Assuming that the helicopter quickly reaches terminal velocity, the function for the time of flight t can be found in the form of t equal this expression, where k is unknown dimensionless constant. Actually, this one, alpha, beta, gamma, and omega are constant exponent to be determined. Questions. Question 12. Determine alpha. Question 13. determine beta. Solution. When a helicopter reached terminal velocity, its distance will be proportional to time. This is the formula for distance h to travel. That's equal v terminal multiplied by time. And from here we can tell that alpha equal 1, which is a correct answer E. Question 13. First, in this expression, only W has a dimension with a time, which is reverse time square. It means that omega equal negative 1/2. But only rho has also units mass as well as a W. It means that gamma equal 1/2 positive. So we know what is omega, what is gamma, and what is alpha, and it's easy to find that beta equal 1. So correct answer is D, beta equal 1.